Welcome back. We're about to implement launch functionality into our API. Let's build our backend to respond accordingly when we're ready to launch our mission. Starting with our chart that tells us the create, read, update, and delete operations that we can perform using our HTTP verbs or methods to create a launch, we're going to be posting to our launches collection. This will let us create a launch that is scheduled for some date in the future. Our endpoint is going to be specific and return a 201 response if the creation of that new launch was successful. And we'll then be able to get that launches collection and see the newly created launch. Sounds good? Let's jump into our code. We can take two approaches here. In our server's source code, we could start at the launches router and work our way through the controller and into the model. Or we could take this bottom-up approach where we start with the most specific details about our model and then build up into the more general controllers and routers. So bottom-up means that we're starting at the base of our functionality, the data model, which is the foundation upon which all of the rest of our functionality is built. Let's start with the launches model. We already have a pretty good idea of what data we need to track. So starting here will give us a lot of clarity on what our controllers and routers will finally need to do. Basically, we need to write a function that our router can use to set our launches in our launches map. So let's create a function, add new launch, and we'll accept a launch as an argument, which will be the launch that we add to our collection, to our map, using the launches.set function, just like we have when we populate our example from when we were testing our getAllLaunches function. So that's a good starting point. Given a launches flight number, which we'll find at this flight number property on our launch object, we want to set the launch at that key based on the flight number to the launch that we're creating. But we want our API to be really friendly to use. It'll be difficult for the client to keep track of what the next flight number for the next possible launch should be. Basically, we want to start at the last flight number and increase it by 1 every time. And the last flight number is a piece of data that lives in the server. So why should the client send it to us when creating new launches, when scheduling those interstellar missions? What we'll do is we'll add some state to our server in this variable, which will say let latest flight number, and that will always be equal to the last flight number that was scheduled. So in our case, we have this one launch with flight number 100, so our latest flight number is exactly that. Now, in our add new launch function, we want to increase the latest flight number by 1, so we can use latest flight number plus equals 1, or just plus plus for short. And now we'll use that latest flight number as the key for our new launch. But we still want to track that flight number in our launch data so that it's returned from our API when we send back all of the values in our map. So if we're saying that this launch won't contain a flight number because it's being set on the server side here, we need to add it to this launch object. So what we'll do is, using the built-in object.assign function, we'll take our launch and we'll assign some additional properties to it. Whatever properties we have on this object that we pass in as the second argument. And if any properties are in both the launch and the new object, the new object will overwrite the old properties in the launch. Let me format this a little bit nicer so you can see what I mean. So we're setting the flight number as the key for this launch that we create in this part of our code right here, which just takes the launch that we got from the user that's getting passed down all the way into our model over here, and we're adding a flight number property that's set to the latest flight number, so that when we get the launches, all of our data is still being tracked. And object.assign will return a new object with the properties from the launch as well as the flight number correctly set. All right, so let's look at our example launch here and think about what the minimal set of data that the client, that the front end, needs to send us to create a new launch. They don't need to send us the flight number. That's something we can calculate. The mission is one of the input fields in our mission control dashboard, so we definitely need to include that. The same applies to our rocket, as well as the scheduled launch date. And we also have the destination exoplanet in our dropdown. But this customer list, well, let's just say that for launches created by our mission control dashboard, our customers are always going to be, let's see, we'll set our customers as 0 to mastery in collaboration with NASA. And more importantly, we know that when we're scheduling a new launch, it's always going to be an upcoming launch because we restrict our launch date to be sometime in the future. It wouldn't make sense to schedule past launches, right? So we'll also say that upcoming is always true for our new launches until we set it to false once that launch actually happens. And we're optimists, right? So we're going to say that unless something goes wrong, our mission starts off as a success. And we can set it to false if something goes wrong. So now we've saved our client from having to send us all of this data that can be determined on the server side. The user only needs to send us these 4 fields that make our mission unique. Okay, so it looks like our add new launch function is setting the flight number, and then between the data passed in through the API and these extra fields we're setting, everything seems to be covered, so we can export add new launch. Here we go. Before we dive into the controller, let's build an example create new launch request in Postman. By looking at what the user will be sending us, we'll have a better idea of how we need to handle the incoming request. So I'm going to duplicate this getLaunches request, and I'll rename it to post/launches. And of course, we need to change the HTTP method to post. In the body tab here, we'll set our body to raw, and specifically the application/JSON content type. So once we click this, notice that our headers now have content type application/JSON, which means that in our body, we can pass in our launch as a JSON object. What were those 4 fields again? We need to set a mission, which we'll name, say, 0 to mastery 155, and the rocket that we'll be using is going to be this 0 to mastery experimental interstellar rocket, version 1. All right, and we'll be targeting, so the destination for our mission, destination with a T, will be, say, Kepler-186f. And last but very much not least, we need to set the launch date when our experimental rocket will fly off towards Kepler-186. And our date, well, it could take a variety of different formats. We could pass in a number representing the amount of milliseconds since January 1st, 1970. That would be what's called the Unix time format. Or we could pass in a string using any number of formats. Say we're being really explicit and we want to say January 17th, 2030. Dates might sound like a small little detail, but if you've ever worked on some piece of code that does scheduling or works with time zones, you'll know that it's actually one of the most difficult things that we do as software developers. So our controller is going to need to be smart when we handle this launch date. But for now, that looks like a good set of data. So we'll save this, and our goal is going to be for this request to succeed. We'll start by taking a look at the launches controller in the next video. Let's take a short break and keep this one going. I'll see you soon. Welcome back. In the last video, we decided what we want the launches request to look like. Our goal will now be to build out the launches controller to respond accordingly to this request. Back in our launches model, with our addNewLaunch function, what's next? We're going to take advantage of the code that we wrote and apply it in the controller. So we're going to import our addNewLaunch function in launches.controller.js. So let's add that right here below getAllLaunches. And our corresponding controller function, which handles our requests, is going to be HTTP addNewLaunch. Taking in our request and response, and at some point, what we want to do is call this addNewLaunch function, passing in our new launch data. The launch data, which will come back through our request body. So because we've added in app.js our JSON parsing middleware, our Express server will now take JSON requests and populate this request.body parameter with that parsed object. So we'll set that to be our launch. And now remember our launches model and that launch date for our mission. Ideally, we'd store it in this JavaScript date object. That's a good starting point whenever you're working with dates. There are more advanced libraries like Moment that we could install from npm, which allow us to add and subtract dates and work with time zones. But right now, let's not overcomplicate things. What we do have to deal with, though, is that JSON, as it's passed in our API, doesn't allow you to pass around date objects. Instead, the recommended approach is to pass the date as a string and convert it into a date when you process it in the API. So what we'll do is just like what we're doing here in our example launch. We're going to take the launch.launchDate property and we'll modify it to be equal to the date object that's created by passing in that launch date. So new date launch.launchDate. Now, whatever value is passed in as that launch date, whether it's a Unix timestamp, which would be a number, or a string containing a formatted date, launch date will now be a date object. And when we add our launch to our map, our dates will be stored accordingly. So what does our controller return? Remember, when we post to a collection and the request succeeds, we want to set the status to 201, which means created. And it's good practice when we create some data in our API to return the data that was created so that the user knows all of their data was processed in the backend. For example, the date was converted properly. So in the success case, we want to return the JSON object for the launch that we just added. And we want to return just to follow the same practices that we've been using up until now to make sure that we only ever set the response once per controller function. Let's test things out. First things first, we need to export HTTP add new launch and add it to our launches router. It's going to be a post request dot post, and again, it's going to be under /launches with the HTTP add new launch function as the request handler. But notice how all of the routes in our launches router are all gonna have this /launches as part of the path. We might change the HTTP method and we might add something afterwards. For example, it's possible we could get just the upcoming launches or just the historical launches. And we could also get a launch by ID. But the first part here is always going to be the same. So there's a cleaner way of doing this. In our app.js, we can make use of the fact that Express allows us to mount our middleware on a specific path. Let me show you what I mean. If we pass in a path before our launches router, say /launches, just like our requests, that match the path for that request, we can also say that this launches router will only react to requests under the /launches path. And what this means in our router is that now we can make things a little bit shorter and less repetitive by just saying / for our get and post routes, where the / means that we're matching the root of the path where this router has been mounted. And all that means is that we're matching /launches and then /, where the / here is not going to affect the matching. So this get route is going to match /planets and also /planets/. It's just that we have to put some string here when we define our endpoints. All right, so this should be a fair bit cleaner. Let's just do the same for our planets /planets, and our planets router now no longer needs to include that part of the path. Very nice. Let's start our server and go into Postman. First off, let's make sure that our routing change works. All right. We're getting our one hard-coded flight. And let's see that we can get our planets. Looks good. What about our new mission? What happens if we schedule 0 to mastery 155? Let's go. Check it out. 201 created, our request succeeded, and our response contains the object that was added to our launches map. Our flight number has been incremented correctly, and it looks like our date has been transformed into the JavaScript date corresponding to the string we pass in. This is a really good start, but we're not quite at the finish line yet because, well, our code is a little bit fragile. What I mean is, what if I pass in hello as the launch date and I try to create a new launch? Well, we still get the 201 created and our launch date is null, which is going to cause problems when we try to launch this mission. The last thing we need when scheduling interstellar missions is to miss our schedule. We absolutely need to do something about this. We'll take a look at adding some validation and improving our new launch API in the next video. And we'll add this new launch functionality to complete the killer feature for our NASA Mission Control dashboard. Let's take a short little break, and I'll see you really soon in the next video. Bye for now. Welcome back. How can we make our launch API a little bit more resilient? How can we make it handle missing or incorrect data without breaking our entire mission control application? When the cost of errors is so high, we need to take some extra time to consider what can go wrong and how to react when something inevitably does go wrong. And once we consider some of these error cases, we'll then connect our new endpoint with our React frontend. Let's dive in. The first step is to validate our inputs. For example, we decided that the 4 required pieces of data that we require from our front-end clients is the mission, the rocket, destination, and the launch date. Now, there are entire libraries dedicated to validation, parsing dates, and error handling in Node. It would be impossible to cover all the combinations of packages and APIs that you might see in various different Node projects. What I'm going to show you will be the foundation. Instead, what I'm going to show you will be the foundation that you can use to understand what sorts of situations you might encounter with any API. How will our HTTP add new launch function respond when one of our required pieces of data is missing? First, we need to catch the fact that there is missing data in the first place. One way we can do this is by checking our request body, which has been assigned to this launch variable, for those properties. Now, there's a handful of different ways you can do this, but you'll often see something like if launch.mission, for example, is null or undefined, that is, it's this falsy value, and when you put the not exclamation mark here in front of it, this if statement will evaluate to true if the mission is missing. And we can do the same for the rest of our required fields. So if the launch mission is missing, or the launch rocket name is missing, or the launch date is missing, and I'll move this to a new line so we can see all of the different conditions, which include our last one, which is the launch destination. We'll say or not launch destination. So if any of these properties are missing on our body, well, we don't want to add our new launch. And we don't want to respond with a 201 created status code. Instead, we're going to return from our controller function, and we're going to set the response status code to 400. Remember, the 400 series status codes represent client errors, and the 400 error specifically is a generic bad request, where the server is saying that it doesn't understand your request because something about its structure or contents is invalid. We use the 400 status code when none of the other common 400 series status codes are appropriate. Most validation that's not security related falls under 400. And we use 404 not found if our request involves some kind of search. Maybe we're getting a item by its ID, and the item at that ID doesn't exist. So when our data is missing, and we know it's required, we're going to respond with 400 and a JSON response that tells the user a little bit more about what went wrong. We're going to set this error property to some message, like missing required launch property. Now, we could respond with just a string, but we've already decided that our API makes use of JavaScript object notation. we're going to be consistent in all of our responses so that our clients can parse our responses in a consistent way without having to check whether the response is just a string or a JavaScript object. Now, what about that date? Can we check to see that the launch date is at least a valid date and not just a greeting to whoever is reading our server's logs? In fact, there's many different approaches that we can take here. Once we pass our launch date property into the date constructor, we can use the launch.launchDate.toString function, which will return this invalid date string if what was passed in can't be converted to a valid date. So we can check if launchDate.toString equals invalid date, then again, we'd like to return from our controller, setting the status code to 400. And this time, in our error message, we'll say invalid launch date. Another shorter way of checking whether our date is valid or not is rather than calling the toString function, we instead call isNotANumber, which is our built-in function to check if a value that we pass in is a number or not. And if we pass in a date object, like we do here, that date will first be converted into a number. So really quickly, in our node REPL, what's happening is, say we have some date that we're assigning to this date object. Maybe it's January 1st, 2030. When we call isNotANumber on date, if it's a valid date, we'll get false. What on earth is JavaScript doing? Our function here, if it's passed an object, first calls the .valueOf function, even if you don't call it yourself. This is to convert the date to a number. So date.valueOf will return a number corresponding to the timestamp, the Unix timestamp for the date matching that object, but only if that date is valid. Whereas if we create a new date, not date, and we try to construct hello, not date.valueOf gives us not a number. There you go. And so, isNotANumber will return true if the launch date was not successfully parsed as a valid date. Just a little side lesson on the isNotANumber function in JavaScript. And when you're typing this function, just make sure that both ends here are capitalized. Or you can use the .toString method that we just saw. Both work equally well. It's time. Let's check if we're catching our errors and preventing some costly mistakes. I'll first save the controller file. And let's run npm run deploy. Now, if we go to Postman and we try to create a new launch with hello as our launch date, hopefully our API will catch our mistake. There you go. Our error object is being returned and our 400 bad request status code has been set. Whereas if we pass in a valid date, like January 1st, 2030, our request succeeds with a 201. And in fact, we can pass in any value here that can be successfully converted into a date by JavaScript's date class. Even a Unix timestamp, which is a number like 1691488000000. So what will our API return? Let's see. A new launch was created, and the date has been set to August 8th, 2023, which is the corresponding date for this Unix timestamp. All right, but what if we're missing the date entirely, or any of our required properties? Let's try removing it entirely. And if we send our request, our first error handler runs before we try to parse the date, and we get this missing required launch property error. Very nice. I think we're ready to connect our new Launches API with our front-end application. Let's keep this one going in the next video. I'll see you soon. Welcome back. We're about to take the final step in scheduling mission using our mission control dashboard. Let's take that API that we've built and connect it to our React front end. We're going to start by going into our requests.js file in our client under source, hooks, and we're ready, just like this to-do comment here predicted. All right, so let's remove that. And what we're going to do is await the promise returned by the fetch function when we make a post request to our API with the launches collection. But remember, the fetch function defaults to the get method, just like when we get the list of all of our launches. The way we make a post request with our fetch function is by passing in this options object as the second parameter and setting the method directly to post. Now, this HTTP submit launch function takes in some data as a parameter. Let's see what's being passed in. We call this function in useLaunches.js. Below where we do our get launches, in this submit launch function that uses the use callback React hook, which basically just takes the callback function that we pass in and saves the result so it doesn't need to execute over and over when nothing has changed. And our function takes in this form data from some HTML form, and it gets the launch day from that calendar picker on our launch page. It takes in the mission name and the other two required fields, and then passes them in as an object to our HTTP submit launch function. So all we need to do in requests.js is to make sure that this launch data is passed in as the body of our fetch request, which is set with the body parameter in our object over here. We'll set the body to the launch object. Can't forget this comma here. But one of the quirks with the fetch function built into the browser is that when we pass in the body, the value we pass in needs to be a string, and launch is an object. So what we'll do is we'll call the JSON.stringify function to convert our object into a valid JSON string that can then be passed directly into our API. And if we're passing in JSON, we'll need to set one header in our headers object. What was the header that we needed to set? That's right, the content-type of the data that we're passing in the body, which is application/JSON. Beautiful. Our launch data is now being sent to our API. But how is our submit launch function being used? There's something we're missing. In our useLaunches.js file, notice that we're taking this response as the result of awaiting for our function call. And we have this to-do here, which is telling us that we need to set this success constant based on the result of our function call. When the success is true, we'll fetch our launches from our API, which should also return our newly scheduled mission here. And then we play this success sound and set the launch as no longer pending after a short 800 millisecond delay. So our front end is tracking the success of our request in this pending launch variable that we track as state, with the default value being false, probably to show some kind of loading spinner and play a success or an error sound, a failure sound in this case, when the request was not a success. And using this response that's returned from our function, we'll then be able to set this pending launch to false once it succeeds, which means that up here, we can uncomment the set pending launch to true, and our front end won't be stuck in a permanent state of pending, showing the user some loading spinner forever. All right, so in requests.js, we can return the result of awaiting our fetch function, which will then give us this response object that includes this response.ok property, which is set when that request comes back with one of our 200 response codes, which means we can set success to response.ok. And our to-do has been done. But not quite. You see, we're all about handling errors in this video. And there's a little quirk with the fetch function where if the entire request fails, for example, the network is down and you can't even connect to the server, or if the server rejects your request because of an issue with cores, well, in that case, the response status code won't be set because the server isn't responding. And so, rather than this response.ok property being false, our fetch function here will throw an error. So we need to catch that error using JavaScript's try-catch syntax, and we'll move our fetch call into that block. So if this await fetch call throws an error, we want to catch it, and we'll call the error error. And what do? We'll return an object that triggers our condition in useLaunches, which is response.ok being false, the success being false and our failure sound being triggered. Back in requests.js, our object will be OK, false. That's it. Now, when an error is thrown, we'll run into the exact same logic that we would if we got back a 400 response. And our success and failure case here will execute just like we expect. Let's see what our mission control dashboard looks like when we submit a new mission to one of our Kepler planets. We're testing our production deployment, and we've updated our front-end code, so we need to run our deploy command one more time. Here we go. In the browser, let's refresh our mission control dashboard. Our upcoming page should have just the one launch from our example that we've hard-coded. And now, if we go to our launch page and schedule a launch for, say, June 15th, 2023, we'll say hello new Earth using the Explorer IS-1 rocket, and we're going to Kepler-62f. Let's go. Oh boy, that sounded more like a failure than a success. We can see that our launch mission triggered, and we have this spinner that shows that we're still pending. So something didn't get set correctly. Let's see if our launch is in our upcoming page. Nothing to see here. Let's take a look at our server logs. Everything looks good. We can even see our post request to our launches endpoint coming into our server. But we see that we got a 400 response to that request. What happened? Let's look at our launches controller. We're accepting a mission, a rocket, a launch date, and a destination, while in our requests.js, well, everything looks fine here, but in use launches, we're passing in the launch date, the mission, the rocket, but a target rather than a destination. There's been a disagreement in how we name things between our front-end developers and our backend. This is totally fine and often the source of healthy discussion. We'll be a good team player and say that for our purposes, both a target and destination make sense. So we'll make the change on the backend. In our launches model, we'll make sure that we're setting the target for the planet that we're aiming for. And then in our controller, we'll update launch.destination in our little validation block here, changing it to target. Now let's restart our production build by running npm run deploy. When our server is running and our front end is being served, let's refresh our browser and go to that launch page. We'll create the same launch as before, scheduled for June 15th, hello new Earth, and destination Kepler-62f. Let's schedule our first mission. We are go for launch. Now in our upcoming page, we should see our newly scheduled mission along with the destination exoplanets for both our example and any mission that we add. We are one step closer to exploring planets beyond our solar system. Let's keep going. I'll see you in the next video. Welcome back. We're doing really well. What remains is letting NASA abort missions that will need to be rescheduled. Maybe it's our rocket that has an engineering issue that urgently needs to be fixed. Or maybe there's some very rough weather that's been forecast on our launch date. What we can safely guess is that when we click this red X, the abort launch endpoint in our API will be called. Most likely, we'll be identifying our missions by this flight number, which is a number that's unique to each of our flights. We can then use this flight number as an ID to query for a specific item in our launches collection. Now, because we're aborting a mission, it's worth thinking which HTTP verb we're going to use for our abort endpoint. For example, we could use the put method to update a launch to say that it's been aborted. That would be a valid approach. But the operation that's closest to aborting a launch would probably be the delete operation from our create, read, update, and delete, from those CRUD operations. So let's go with that. Our delete operation will return 200 OK if it was successful, and 404 not found if the ID of the flight we're trying to abort was not found. Let's explore how we might build this delete endpoint from the top down. Starting from the functionality that's closest to the user and our front-end dashboard, going down into the implementation on the server side. Just like the bottom-up approach, this is also valid. So let's get a feel for doing this top-down. In our client, we'll start by looking at what happens when we click that X to abort the launch. What's going to happen is on our upcoming page, somewhere here we'll call a function when that X is clicked. Right here we have the table of upcoming launches, and for each link, we have this onClick handler that calls abort launch, passing in the launch flight number. This abort launch function is coming in to our component from this hooks file under use launches. Right here underneath where we do the submit launch. And what happens in our abort launch is that we call our HTTP abort launch function, which we already know is going to be in our requests.js file and empty, telling us that we need to fill it in with our call to the API when we want to delete a launch with some given ID, which is passed in as an argument. Let's see if we can fill this in before writing the actual API. Let me clean up the comments. And in our function, we already know from our previous functions that we're going to want to return the awaited result of our fetch function, fetching our API underscore URL, and this time we're talking to the launches collection. But here's where it gets interesting. we query that collection by passing in this ID for our launch, for the flight number that we want to abort. So I'll pass that in as a template string. And remember, our fetch function is a get unless we specify a different HTTP method by passing in this method parameter in the options object, saying that it's a delete operation. Now let's look at how our function is being used. In useLaunches, we can see that the response from our function is being used to set this success variable that determines whether we need to refresh our launches if it was a success, and what sound to play depending on what happened. So just like in our submit launch case, we'll want to catch our errors. For example, if our internet connection is unreliable, or the server rejects our request because of CORS, and we'll do this try-catch handling just like we did before, so that in our useLaunches file, we can just set the success to response.ok. Remember, we don't want our fetch call to have different behavior if the server responds with a 400 response, which would set this response.ok to false, versus when the network is down and this response.ok would normally not be set because an error is thrown. So we'll try this fetch function and catch errors, which we can log, but we then want to return this object with the OK property set to false. We now have a clear path forward to making this work in our server. Let's build out the corresponding route in our launches collection under launches.router.js. Our third endpoint here is going to be launchesRouter.delete, and we're going to pass in slash because we're at the root of the launches collection. But this time, we're going to use Express's parameter syntax to say that we pass in a parameter called ID, which we have access to in our route handler, which we'll call HTTP abort launch. That's going to come in from our launches controller right here next to our router. We can add our abort launch function. So function HTTP abort launch, which takes in a request and a response, which we know, of course, we have to export from our module. First thing, we need to get that launch ID, which is passed in as a parameter to our route. So let's say const launch ID equals, and remember how we get our request parameters? It's request.params, and then the name that we put in our route. So in this case, :ID means that we can call in our controller request.params.id. Now, our controller needs to make use of our launches model to abort a launch. Let's think about this for a second. We have this map where we can look up flights by flight number, and our controller will need to check whether that launch exists, returning 404 not found. So if launch doesn't exist, return response.status 404, and we can tell the user in our JSON object that the error message is launch not found. Whereas if the launch does exist, we'll want to return our successful status code, so 200, and in the body, we'll pass in the object that we just deleted or aborted. So our user at NASA knows that they aborted the correct launch. Now, we could separate this into two separate operations in our model. We could look up whether the launch exists, and if that returns false, we would return this error, and then we could delete our launch as the second step using a separate function in our model. Or we could try doing both of these operations in one model function. Let's take a look at the first possibility. In our launches model, we'll create a function right above getAllLaunches that says function exists launch with ID, and we're passed in a launch ID where we just return from our launches map whether that map has an element with the key matching that launch ID, where the launch ID is actually the flight number. So in our controller, we could say first importing our function, which we called exists launch with ID, that lives in our model, and we'll call that to check if our launch exists. So if exists launch with ID launch ID, and we're checking actually if a launch with that ID doesn't exist. So if not exists launch with ID, return launch not found. And then how do we abort our launch? Well, let's create a function right here at the bottom of our file. Function abort launch by ID. And again, we pass in a launch ID, and we do something in this function. First, let's make sure that we're exporting exists launch with ID and our abort function. There we go. Now, we're not done yet. Our code probably still has a few issues, but this video is getting a little bit long. So let's take a minute break, stretch, and get right back into that abort function. We're just getting to the good part, and we're going to discuss some interesting things when it comes to designing models. So I'll see you really soon. Welcome back. In the last video, we started using the top-down approach to implement our abort launch functionality. Starting from the front end, going down all the way into our launches model here. We made some good progress, so let's jump right back into it. All right, so how do we abort? We could call the delete function on our map object. So launch.delete, passing in our launch ID. And that would completely remove our launch from our model. But instead, we're going to do what's common with internet applications in the era of big data. We're going to keep the launch data that was aborted, and instead of removing it, we'll mark that launch as aborted. After all, that data is still useful to us. So instead, we'll get the launch with that ID, and we'll assign it to a variable, a constant we call aborted. And on that object, we set aborted.upcoming to false. After all, aborted missions are no longer upcoming. They've been canceled entirely. And similarly, we'll set aborted.success to false. Even though our aborted object is constant and we can't reassign it, we can still mutate the properties inside of it by setting, for example, upcoming to false. So our mission is now going to be in our historical list in our front end, and it'll be marked as not successful. Exactly what we want. So in our controller, we'll say const aborted equals abort launch by ID, passing in the launch ID, which we now know exists in our collection. And because we need to get this aborted object for our return body, we need to return it from our model function, return aborted. Looks good. Now, how is this different than if we had done everything, including whether our launch with that ID exists, all in one function? Well, we could probably save ourselves from calling this launches.has function by just using the value returned from launch.get, which should actually be launches.get. After all, we're checking the launches collection. This is why it's good to review our code. So we could use the value that's returned here to check whether the launch with that ID exists or not. Aborted will be undefined if the launch with that ID does not exist. But the get function, as well as the has function from our exists launch with ID, are both relatively inexpensive. With maps, it's very efficient to check whether an element exists and to look up elements by their ID. And the added benefit of separating these two functions is that we now have this utility, exists launch with ID, that we can use for any future routes that deal with launches. We have a fairly simple use case here, but these are the kinds of things that you might want to consider when building your models. And it's good practice to use the same order for your exports as you do for your function definitions. So I'm going to put exists launch with ID right at the top here. All right, I think it's time. Did we do everything right? Can we make requests that abort launches? Let's try deploying our server and see what happens. npm run deploy. All right, looks like we missed something. It happens. Node is telling us that our HTTP abort launch function has already been declared in our router. Let's take a look. All right, again, it's just VS Code automatically importing the wrong file here because we have the HTTP abort launch function in our client as well as in our controller. So I'll remove the client, save the file, and give that another go. Our server is listening on port 8000. Let's try making some requests in Postman. First, let's try creating a new launch And we'll set the launch date to be July 1st, 2028. Let's see if that creates successfully. We're getting missing required launch property because we renamed our destination to target. All right, I'll save that request and try sending it again. Looks like it was created with flight number 101. So now if we create a new request, say duplicating our post to /launches, we'll rename it to delete/launches/ID. We'll change the method to delete and pass in, say, launch 100, which we know will always exist because it's hard-coded into our server. We don't need to pass in a body, so I can remove that, selecting none, and I'll save our request, and let's see if the launch is aborted successfully. Launch isn't found. What's going on? If we get our launches, let's see what we get back. We have a flight with flight number 100, and we have one with flight 101. So our delete call should be working. The problem is that when we set this ID by getting it as a parameter in our request object, here in our controller, it comes back as a string. And our index, our ID in the map of launches is a number, an integer like 100. So what we'll need to do in our controller is convert our string into a number, which we could do any number of ways. We could use this shorthand by adding a plus, or we could be explicit and call number on our ID string. Now we'll be able to find launches in our launches model. Let's give this one more go. Let's go to Postman, create our new launch, and try deleting launch 100. Very nice. We're getting our 200 OK response with the object which has been aborted by setting the upcoming flag to false and the success flag to false as well. Now, if we get our launches, we'll see our flight 101, which is upcoming, and our flight 100, which is no longer upcoming because we've canceled it. Let's check our validation on the abort endpoint. What if we try to delete launch 188, which we know doesn't exist? Looks good. We're getting 404 not found. And in our browser, if we refresh our NASA dashboard, we see our newly added flight 101 with flight 100 already removed. And if we go to the upcoming page, which we're already on, we can now abort launches by pressing this X right next to the corresponding launch. Let's give this a go. Check it out. Our launch has been aborted. We can now add launches by scheduling them through our mission control dashboard, scheduling them for launch, and then aborting them as necessary right in our upcoming page. Finally, if a launch is aborted, it appears on the history page as an unsuccessful launch with this red indicator next to it. We've completed the basic functionality of our NASA Mission Control dashboard. Congratulations! I'll see you again in the next video. Welcome back. We started off by building this basic architectural diagram in Lucidchart. We haven't forgotten about it. As we figure out the structure of our project and our project grows, it's important that we keep our project documentation and especially any architectural diagrams up to date. This is part of what differentiates a senior developer or a strong intermediate developer from someone more junior. Andre wrote this really great article called "Don't Be a Junior Developer." If you haven't read it, I highly suggest you check it out. You might be saying, "I'm just getting started. I'm still studying. And I'm definitely a junior developer." Well, that's absolutely fine. But this is the point in your growth where it pays best to invest in yourself. And by learning the skills you need to be a senior developer. Don't be afraid of trying new things. And definitely don't sell yourself short. You're capable of more than you think. So let's have a little bit of fun improving our architecture diagram. First thing, I want to make it a little bit more obvious that our mission control project is a loose grouping of our web application and our Node API, which are both Node packages. So I'm going to use this dashed line over here, and I'm going to make the background transparent, maybe giving it a light shade of blue so that we know what's in this box captures our NPM packages. Now, if we go to our code, we have our root package JSON where our project is named NASA-project. We have our server package where our project is called NASA-project API, and our client is called NASA-FE for NASA frontend. So it's more useful in our architecture to know which packages each component relates to. So I'm going to update our web application here and say that this is the NASA-FE project. Our Node API is NASA-project-API, and our entire mission control project is NASA-project, which I'll move to be justified at the bottom of this box. Now I'll zoom out a little bit so we can add some extra components to our diagram here. So actually I'll move all of these components over. And we're going to add the web browser as a component in our architecture. This is what interacts with our NASA project and specifically talks directly to our web application to get the HTML along with our React code, which makes requests to our Node API. So I'll make this a different shade because it's outside of our node code. Maybe it'll be green, where green will represent devices that interact with our NASA Mission Control project. And we'll make sure to mark that our web browser talks to our web application over the HTTP protocol. By the way, if you're not able to see the shapes that I'm using here, you can search for them with this search icon here. For example, looking for flowcharts, which will give you the flowchart shapes I'm currently using. Or you can add shapes with this plus shapes button here. There's plenty that Lucidchart makes available to us, from Android mockups to even circuit diagrams. The ones that I'm using are geometric shapes and the standard shapes for Lucidchart. You can be as fancy here as you like. For example, I'm not quite satisfied with my dashes here. They're a little bit too distracting. Much better. It really helps to make our diagrams look nice and readable, because only then will people actually look at them. Documentation that's not read and referred to is just a waste of time. But brief, nicely formatted documentation can make everyone's lives easier, especially the project architect or senior developer when they have to explain the project to potential customers or executives. Now, I'm going to change both the interaction from the web browser and the interaction between the web application and the Node API to be bidirectional. That is, we're not only making requests one way, going from our front end to the API, but we're also getting responses back, which means these arrows need to be pointing both ways. We're not done yet. This isn't quite a complete picture of our project as it is today. We're filtering the list of potentially habitable exoplanets that we can target with our missions from the set of data made available by the NASA Exoplanet Archive. Our project depends on the NASA Exoplanet Archive to provide these CSV files with the data observed by the Kepler Space Telescope. What this means for us is that our Node API relies on this document, and I'll use a solid line this time, which, if we remember in our project, in our server's data file, data folder, is called Kepler_data.csv, which stores our downloaded exoplanet data from the Exoplanet Archive. So, this is going to be Kepler_data.csv, which is depended on by the Node API. And this is a direct requirement, so I'm going to use the solid line again, where the API reads in data from Kepler_data.csv. And this file originally comes from the cloud, which specifically the NASA Exoplanet Archive. And we download from this using an indirect sort of manual process by going to one of the Kepler tables and downloading our CSV file. So I'm going to label this as a manual download, just so we're clear on the data flow in and out of our project. And we can color code this to make it even easier to read. So let's make the exoplanet archive. This color, I believe we can call teal, where we can also group this CSV file as coming from a similar data source. But this time, maybe we can make it slightly more transparent, maybe 50%, because it's partly from the NASA Exoplanet Archive, but also it's included in our NASA Mission Control project. And there we have it. We can keep cleaning this up bit by bit and updating it as we build out our project. When working on real-world projects, good documentation will be the language that you use to speak to many of the people who will never get involved in the code, either because they lack the time, maybe a technical team lead is busy on other tasks, or because they lack development knowledge. Maybe it's a non-technical manager of your team. Think about it. If we spend lots of time making our code nice and readable and efficient, we should also dedicate some of that time to our documentation. Trust me, your team will notice. All right, I'll see you in the next video.